Hi everyone, my name is Mike Aubry. I'm one of the evangelists on the Fusion 360 team, and this is a video to help you get started doing your first script in Fusion 360 with Python. Fair warning, I'm not a coder, and that actually will be really good for some of you guys, and it'll be terrible for some of you else. I did a little bit of C++ in college. I'm a mechanical engineer by background. I've been in the CAD industry for about a little over 10 years now. If you're a real coder, you're going to have a bad time, and you should instead take a look at Brian Ekins getting started in Fusion 360's API video. That's going to be a lot more cut to the chase, a lot more meat from the beginning. So here's a link to that. Going to do it. So for the rest of you, this is a video that I've made to help you getting started in scripting, and it isn't comprehensive. But the idea is I've just started doing my Python scripting, and I know there are some hurdles that caught me up pretty bad, and I wanted to help it so that you guys didn't have to go through that as you start to program stuff. So I'm going to be running you through basically the first substantial script that I created, along with showing off some of the resources that I've been using along the way. The first tip I have for you if you're just starting off in Python and Fusion for the first time is don't feel like you have to use only Fusion 360's ODE environment to do your coding. So what Fusion uses is an ODE environment, open developer environment called Spider. It runs on Python 3.3. And what I actually found as I was just learning off Python for the first time was actually using this guy, this little PyScripter was easier for me to get used to doing stuff in Python. And let me show you why. The reason why is that Spider requires you a lot of times to use a lot of the objects and methods in Fusion. So there's a lot of extra code that you wouldn't have seen before ever. This guy just is pure open Python. And so if I want to do simple things that you see in all the online tutorials of how to do things in Python, like for instance, let's just do a hello world script. If I just call it a variable, so let's call this hello one equals the string of hello world. So we're going to have this thing just print hello world. I'll say print hello. So that's the variable that's equal to the string of hello world. Hit play, and whoa, sweet! Look at that. It just puts out hello world. Let's compare that. If you if you do that in the Spider environment, this can be very frustrating if you're trying to use that print as ways of showing that calculations have happened accurately along the way, or if you're using just a general check. This print actually isn't one that's pulled in the ODE environment. For Fusion. So actually this guy, if you do the same code, it's perfectly valid code. It'll give you an invalid syntax, and it's just, I don't know what that is yet. I haven't coded long enough. So it's this sort of stuff that's just, it's not going to throw you off once you get used to it. But if you're just starting off, just chill out. Go download this guy, PyScripter. And there's a bunch of them out there, but this is the one I liked. I downloaded this 2.5.3 64-bit executable. It's really easy to install, and it's not 3.3. It's an older code, but it checks out. And the stuff that we're doing here, there's no difference between the two. Just download it and get started. That's my first tip. Here's a couple of ones that I used to learn that I really liked. This first one is Python Programming by Derek Banas. This guy, he runs a tight ship on his videos. He's very quick, very thorough. So I really learned an awful lot from Derek, and I'm really appreciative of his videos. So give that guy a try. And the next one is actually this Code Academy that was set up by our very own at Autodesk Patrick Rainsbury. This is a course you can run through and do a lot of stuff just kind of on demand. So I'm going to quick run you through next how to do the Fibonacci sequence in Python. So it's just going to be me kind of walking you through the code. This is available a lot of places. This is not, I'm not God's gift to loops. This is I figured this one out, but on my own. But it's certainly published 1,000 different places. And so I'll quick run you through that, and then we'll convert it to Fusion. So let's go back into PyScripter here, and we'll get started. Now that we have this hello world, let's get rid of that. That's far too basic. What we're going to do here is we're going to be doing the Fibonacci sequence, which, as you'll recall, is just you take these basically each number along the way, you just add the previous one. So 0 plus 1 equals 1, then 1 plus 1 equals 2, and then 1 plus 2 equals 3, then we go to 5, and then it goes to 8, and so on and so forth. And so this is a great example of where you can use a for loop. I'm going to start off just by calling my initial variables of what we want to use. And so we're going to have basically that there's the first value and then the second value that need to be added together. So actually I'm just going to call them like x, let's call this x1, and then we'll call the next one x2. I won't worry about starting from 0. We'll just start it from 1, and then the other value is going to be 1 as well. And so this is just to kind of make sure that we know what these things have done. This, I like to do these little kind of print things along the way. So I'll print, I'm going to print x1, and then we'll print x2. We'll just call these things, actually in a comment, we'll say start x1, and we'll call this thing start x2. Then we can kind of make sure that everything got in. All good. There's start x1 is 1. All right, so the next thing we got to do is we've got to start giving it a loop of basically how many times, how many Fibonacci sequences do we need to go out. And so this for loop that we'll be using, we need to give it a variable to say how many steps to go through. And so I'm going to call out, it's actually going to call this thing steps, and we'll just say I want this thing to go 10 steps. And actually, I'm even going to add a little note here and say that this is going to be the note of this is how many Fibonacci steps to go through. My first two sequences that we put out are actually going to be just my starting variables. So I'm going to actually say I want these things basically print down here. So instead of having this print field here, I'm actually going to get rid of that. And I'm going to go down here and just say, well, let's just print x1, and then we'll print x2 now that we know it's working. And those will be our first two sequences. And then the third sequence is actually going to be started up by basically, these are 1 and 2, so we don't actually want to go 10 steps. We now just want to go 8 steps. So actually, let's call it a variable for this for loop that we want to go 2 less than what the steps are. So we're going to call that variable r, which is just going to be steps minus 2. Pretty easy. Awesome. And now we're ready to start doing our for loop. And so you can look, here's a great link that I used. I guess I'll cite actually I should cite it right here in my code where I got my for information from. So cite my code. For loop code reference. Great video. Check it out. And so for the variable of I, there we are. Yeah, in range. So for I in range of R. This is where the tabs matter. So now we're saying this whole thing will be contained within these tabs, tabbed in spaces. So I'm going to call it a new variable. We're going to call this thing x3 is going to be equal to x1 plus x2. So this is x3 is the next value in the Fibonacci sequence, right? Because we're going to add these guys together, and the first one will be 2. This is great. It'll do this, and then after you've done that, then we need to progress things on. That the new, basically the new x1 is going to progress on to become x2, and then x2 is actually then going to become x3. And then x2 is what we need to actually print. We're going to have actually in that sequence there. So we're going to say we're going to print x2. And we're done. So basically this will go, it'll do this operation as many times as is R, and that's going to be this guy. And let's see how we did. So we'll go ahead and just quick save this guy. We'll call it Fibonacci tutorial. I'll post this as well, assuming it works. And we'll go ahead and hit play. And then, oh, look at that. There are our Fibonacci sequences. And so these values will be what will, this basically underlying logic will be what we'll use to convert into our script in Fusion next. Right now this code is just giving it's just outputting values, but what we actually want to do is we want to start outputting individual coordinates. And so that's kind of an interesting exercise of basically going going right, then up, then left, then down, then up, and going around a corner. So there's like this addition subtracting thing. And so actually the way we're going to go about that is there's some interesting stuff we can do with range functions in Python. And let me show you how that works. So what we have is the range can be used as we've used it before. And just say if I do something like x equals 6, just say x range equals 6. And if I want to say print the range of x range, it'll actually print all of the integers that are within that range. So we'll say print, and it'll do 0, 1, 2, 3, 4, and 5. So those are 6 integers in there. It starts as 0. You could also go a step further than this and say, like, if you actually say you can tell it where you want it to start from for that range, and also on what increments. So in this case, if we do start on 1 for the range on every first one, we hit play for that, it'll start at all the integers that follow from 1 onwards. So 1, 2, 3, 4, 5 within the range. if we go and we start, if we want to say that we want it to actually go on increments of 2, it'll actually do it on increments of 2. So then it actually gets a lot smaller there. So it'll only do the ones that fall within the range of 2. Where this gets to be super handy is if we want to make it so that certain actions for updating our coordinates only happen on certain increments within that for loop that we designed. This is a really handy way to do it. We can have these little bins of saying in certain scenarios I want you to go left, in certain scenarios I want you to go up, in certain scenarios I want you to go left. And so that's what we'll be using these ranges for, and we'll be using them within and if a certain condition exists, do it this way. So here, we'll go in and jump into that. So if we go back to our Fibonacci sequence, we no longer need to just do it in a Fibonacci output the values. This is what the values actually going to be using to go in left, right, and up. So we need to have some variables for what our new coordinates are going to be. So we're going to actually say for these variables, I'm actually going to call this the x coordinate, that value. The default state is going to be 0, 0. We're going to have something right at the origin. So we're going to have a y coordinate. I'm going to call this out is coordinate, and that's going to equal 0 as well. And then what we'll be doing here is this is still going to be the same, so everything within this range of r, and so we'll keep that r there. We'll leave it there, and this is going to be our new Fibonacci value. But we want to be making sure that we're starting to create something for our actual plotting of xy points as well. So let's go ahead and we'll start calling out some bins to make it so that these different variables will sit within. So actually I'm going to say that the bin 1 is going to equal the range for when it's going to be right at the starting point within R on basically every fourth time, because it's going to be going up, down, left, right, okay, north, south, east, west. When it starts there, that's going to be in bin 1. And then we'll say that bin 2 is going to be the same thing, but it's just going to start at a different point. It's going to be like when it goes within the range, starting at the first integer instead of the 0 integer. So we'll go with that, and then we kind of just keep moving on. So bin 3 will be equal to range 2R4, and bin 4 will be range 3R4. And this will determine what gets contributed to what. Now we got to add some if statements. So if whatever is going to be, so we're going to say if something contains within I and something within the bin, we're going to go ahead and we're going to add it to that coordinate. So what that looks like is here to show you what we're kind of working towards is this syntax, if within certain scenarios. Here, let me copy and paste this over here for clarity. So here we're going to say that this guy, just within this for statement, so if I, it's using the same I, is within bin number 1, that's this guy up here. If you're going to do that, then you're going to do the following. It's going to say the x coordinate is going to continue to just equal the x coordinate. No big deal. I'm just kind of doing that just for clarity's sake as we go through this. And we'll say that the y coordinate is going to equal to the y coordinate, the old y coordinate, plus whatever that old x2 is going to be. So this guy right here, x2, there, and that'll be the first condition that exists. So then, so that's going to be one of those things that basically that first one is going to go in the y direction. So it's going to start at 0, and then it's going to move up of the distance of that Fibonacci sequence. And then the next thing it's going to do is in the next part of that sequence is we'll say if I is going to be in bin number 2, well, that's going to be different. In this case, we're actually going to be going that it's going to be the x coordinate, and we're going to say we're going to move backwards. So wherever it is along the x, it's going to be minus x2. So that's going to be the next sequence there. And this will just be the y coordinate. No problem. And then we'll go on and we'll say if it goes in the third, you see a pattern emerging here. If it's within the third bin, this is actually going to be added. Oh, I'm sorry, actually it added right there. So actually it's going to be added first. So now we're going to be subtracting to move it down. And then the final one, we're going to go the opposite of what happened in bin number 2, is bin number 4 is going to be this guy. So now we have all these different values here that are happening. The other stuff we want to be doing as it's doing it is it needs to be outputting the values from that. So like what we have in each of these phases, actually in my cleanup code, I'm actually outputting the strings of those values. So actually I have this little code right here, and I'm using different names for the variables in this example. So let me go back here and we'll clean this up so it works here. Basically in this if statement, it's going to be pulling out, it'll actually do a string value. That's what this is. So it's got some kind of some syntax to actually output little brackets and a comma and some brackets here. But I'm going to say actually the string of the x coordinate value. And I'll output the y coordinate value after each of these phases. And this is what it's going to be pushing out. So actually at the beginning, actually we probably should have this push out those values too. Let's do one more thing to clean up that first coordinate value. I'm just going to add at the beginning. So I'm going to take this guy and just say from the get-go, now don't worry about doing the for loop here. Just give me that second coordinate, and that'll be actually just the x coordinate will then equal to 1, and then output those values. So we'll just quick save it, hit print, this guy, and then we see, yep, there's 0, 0, there's 0, 1, and okay, we're ready to go. Next up, let's go ahead and we'll start converting that Python code that we just created and put it in a format that Fusion 360 can use to create a sketch in Fusion. So first thing we got to do is we got to create a script. So just go up in Fusion, this script and add-ons, and just start one. So we can say create right here. And we're creating a script. It's not an add-in because it's not launching on start. It's not pulling references. It's just a script. Go Python, and then we'll just call this the Fibonacci tutorial. And this is going to be where it's going to save. Go ahead and create it, and you see there's our axis right there. And go ahead and edit it, and it'll launch into Spider. And you'll see kind of that starting code, and we'll just go and we'll do away with this, and we'll start programming our own. So if you well, if you're like me, you don't have any idea of like, okay, great, Mike, you've got this great Python stuff now. How do we start calling stuff from Fusion? And well, we go to the internet. That's the thing. And so I want to draw your attention to this place, this location. It's called the learning part of Fusion. Draw your attention to this programming interface. This is going to be your friend. And the one specific area that I found especially useful for me starting off is these sample programs. And specifically, I want to draw your attention to this under the sketches option. So under modeling, sketches here, there's one create a circle by center and radius, and there's another one to create a spline through points and creation. We've got basically some starting code that we can start using to parse together and put our code intermixed with it to get what we want. So there's a lot of great stuff here just available. So I'm going to go ahead and just copy this stuff and let's get started. So we'll copy this and we'll put this into Spider. And then next up, I'm going to run you through kind of how to read this stuff. Because if you're like me, this whole doc.apps.documents.add.autodesk.core.document types, that can be a little intimidating. So let's break down what it actually means. So what this is showing kind of start to finish is you start off by importing what are called libraries of these different objects, which is what we're looking at here, documents and things like sketches. These are objects that contain with them basically series of basically code, which are ultimately manifest themselves in these things that are called methods, which you can access stuff from within Fusion and have it execute without you having to actually code it. You're using Fusion code to do it. So what we're doing here is this is basically allowing basically enough stuff to be accessed so you can do just that. So you start off by importing basically the Fusion magic codes, which are these libraries. And this, the first one is the core, the .core from Autodesk, and then the Fusion object set. And then this traceback is basically what you pull in you can use this try and accept object or method object thing. And so to simplify things, actually here we can just start by getting rid of the traceback. And actually let's simplify our code even more because we weren't going to need that for this first little example. And then I'm going to pull in the indents. And let's look at what else it's doing. So if you look at the at the very top, just below the imported libraries, it starts out by calling off a variable that's called app. And so what app is doing is it's pulling in, it's getting all of the it's getting all the objects from core. So it's pulling those in, and then it's also pulling in all of the all of the so from the application, it's also pulling in the objects within the user interface. And well, okay, that's great, Mike. What is the app interface that the UI is accessing? Well, I'm glad you asked. Let's go back, and I'm going to introduce you to another really kind of handy tool here in on the interwebs. If you look in the Welcome to Fusion 360 API section, there is an additional resource called the Fusion Object Model. If you click on that, take a look at this. This is that. This is what you've imported right here, and this is your object model of things you can call out. So we mentioned about how we're pulling in the user interface. Well, that's what we're doing right here. So this guy, this application user interface, is what you can use for things. Eventually, we're going to be pulling in to do things that are basically like the print command before. This is where we would go to do things like message boxes, or we'll come back to that. So that's what that's doing. And the next thing you see in this next line is this doc equals the app documents, and it's actually adding a new Fusion document to this code. I don't really want to do that, so I'm going to delete it. And the next thing we've got is this design variable is equal to the app, so the application, and the active product. So that's basically what's open at the time. And then this next one is the root component variable is going to be equal to design, which is this. This is the app.activeProduct, and then it's the root component. And so that's going to be the component within the Fusion document. So for instance, if we go back to Fusion, look at this, that's going to be this guy. Remember how components are like parts and assemblies. So this is just that top level component that it's going to be basically creating ultimately a sketch within is what we're going to be making. Go back to Spider. Next thing is it's going to be saying let's create an XY plane. And so that's what that note says. And so we're actually going to be creating a variable here called sketches, which is the root component sketches. So if we go back to our object model here, you can see under the doc section here, where we're invoking the documents, Fusion document, the component sketches right here. And then we're going to be pulling eventually the sketch, which is where we're able to get all of our different things like sketch curves and sketch points we'll be pulling in, and then also the sketch circles, which is what we're showing in the immediate example. So that's what we're showing here in Spider. We can see that the XY plane is now going to be pulled in, so the root component XY construction plane is what we're going to be using. And then the sketch variable is going to be take the sketches object and then add this sketch to the XY plane. And then the notes here, we're going to draw some circles. So the variables of the circles variable, that's going to be pulling in those objects. So the sketch.sketchCurves.sketchCircles, that's what this whole little string is here, and this big map of just amazing clarity. And then we get to the fun stuff where we say circles add by center radius, and you can see that it's pulling in. Basically, this is called you're pulling in your point, which is what this is, and then it's going to add of a radius 2. By the way, the absolute units that Fusion uses by default are centimeters. So this will be a 2 centimeter radius. And then it'll add another circle, it's going to be 3, and it's going to be at a different point on that sketch. That'll be 8, 3. And then it's going to, and then there's another code to add a circle at the center of the existing circles. I don't really want to do that, so I'm going to get rid of that. So let's just take this code right here. I'm going to save this and not worry that it's not creating Fibonacci quite yet. We'll just use this to create a circle. Well, let's see how it does. So I can hit play right here. Go ahead and try that. And you just go back to Fusion. Actually, we'll go ahead and see. Let me turn off some of these bodies here, and you should be able to see that sketch got created. Turn off this guy. There it is. There's our 2 circles. Oop. Yeah. Let me, for just dramatic emphasis, let me redo this again. So another way to get at that again is just go to create a new part. New file, go to your scripts, add-ins. So the Fibonacci tutorial is what we're using right now. Just go ahead and run that, and then it'll create your sketches. And so what it did is that it created a sketch on the XY plane. You can see that it's right there. There's your XY plane, and created it. So that's real quick how you can make some quick geometry. Let's take that and we'll parse in some code to start using our Fibonacci loop. So now with Fibonacci, we're going to be pulling in points. We're actually going to be doing Cartesian points to go around in a spiral fashion. So we can't do a circle here. So we need to get some different code. And so I was mentioning, we go back now to see how would we do that. And so we have this actual example, sketch a spline through points creation. And so this actually will define the points to fit through. We don't want JavaScript, we want Python. And so we see there's actually a lot of stuff that's pretty similar here. They're still creating stuff on a sketch. They're still pulling all the initial code in. This is just, we need to have a variable here that's called points that's going to be pulling in the object create object here. And then we need to actually add different core points. And then after that, there's going to be some tools to create, to basically connect to the splines. So we'll just take these guys. That's all we need. We need these guys here. Just copy and paste you, and we can make sure this works by going just back into Spider. So we'll go ahead and turn off, well, I'll turn off the circle in a second. So if I want to, so I'm going to pull these back. So I'm going to quick turn off these guys because I might want it later. So I'm going to go ahead and just turn them into comments. That's kind of a cool way to just kind of turn things off for a little bit. So these guys are sticking around. And then the sketch, we still need to have the sketch here. So the sketch equals sketch curves. And why is this guy unexpected indent? Oh, I need to get rid of that little space there. Yeah, okay, we're good. Hit save, hit play, and let's see what it did. We'll start a new little instance, go back to Fusion, and then there's our spline. Wow, that's really cool. And so it does create a new sketch each time. Anyway, so it's working. So it's pulling in points. Now, what points might we pull in? Well, this is where we get to go to our Fibonacci code. So if we go back to PyScripter, so let's take this code now, and now the battle becomes, let's take all this stuff, and we want to then, rather than printing it out to just in the interpreter, we want to actually have this plot to a Fusion sketch. So I'll take actually, let's take all these guys right here, next two, and then we're going to go back into Spider now, and then basically below all of this stuff, the importing basically everything. You have these application gets the design under this root component, creating sketches and creating a new XY plane. Below this is going to be where we need to put all of our code that's going to be doing some actual calculating. So here's our beginning variables, and we'll call this out actually in the notes. We'll just say these are our starting starting points, or starting points, and these will be our first coordinates. And we'll call this the second coordinate. Just these little notes. And what we need to do is where these prints are occurring, these print values, and actually these are just for our own seeing that things are working. These guys are the ones that need to actually plot to the sketch. So what we'll do here is we know how to do that. We already have our code for it. And so we have these points object create. So actually this guy will go up top, kind of below this other stuff. So those are just, calling in the objects. And then these print values, that's actually going to be these guys. So we'll take this, cut this in, and rather than this, we'll print this guy. And this is going to be the x coordinate value. That's what this is. That goes into the x. This guy right here goes into the y. And there's our first value. And then we'll basically do the same thing here. Copy and paste that in. That'll work. So now the points will be there. And then we aren't going to need these. Those will be our first ones. And then the next thing we need to do is we need to then, where the print is, we don't care about this guy. That's going to be one of those things we just had just to kind of check in and make sure things were working. No, don't have to worry about that. These guys, it's going to be the same stuff. You're going to be plotting that x, y, y coordinate, so we're just going to swap this stuff out. Okay. And let's see how this thing goes. So I'm going to quick save it, and let's print it, or plot it, I guess. Run the file, and let's see what we got. And there it is. There's our new sketch. Look at that. That's our Fibonacci sketch. That's pulled right in. I think that's pretty neat. So yeah, every time you want to do this, we want to go back and change some of our values. If I went back into Spider here, I could go in and say like, well, actually, I want this to not start from there. I'd like the starting x coordinate to be something like, let's go out to let's start from 5 5 instead. So 5 5, and actually we'll make this thing be the previous x coordinate plus 1. So you can see it's really easy to just start kind of adapting your code to start from different areas. So we'll say x coordinate. See, we'll go and pull this thing in there, save that, and let's see how that changes. So this will go back in and updates thing. And so all it does is that just offsets where it starts from. Really fun. So you can go in, and I've created, so I've made different scalar values to make it so this thing is just bigger or smaller based on initial inputs. I've made it so that you can pull in different planes. There's actually an entire video here. I'll show this right here of kind of where you can go with this script, which brings me to my final tip of what happens when you want to do something and there isn't a sample. And the answer to that is don't be afraid to ask questions, because it's really important that you get involved in our community, because your questions are the questions likely of others in our community, and we're trying to build out better documentation so that everybody can use it. So a great example of this Fibonacci going to the next level. This is as far as I was able to get on my own, but where I really wanted to go was I wanted to make a script where I could create a loft that would make a circle around it. So this horn of Fibonacci I did an entire video on. I wanted to make it so it could automatically create this. And where I got caught up was in my scaling function. I didn't know how to make it anything but centimeters. And so what I did is the final place that I'd like you guys to go in this kind of getting started tip video is the tip is go to the tutorials, or not the tutorials, go to the forums. So where this is actually, if you go to fusion60.autodesk.com, in this area here, if you go under the community section, if you go to the community home, we have a really active and super eager to help API and scripting discussion channel. Go here and ask your questions. So this is so what I was able to do actually. Could I actually, let me go to one of the older ones I had under. I had some interest. I wasn't sure how to make things change from centimeters into something that was predictable. So I asked this question of where is this certain this string that I had, that this object method is, where is it pulling from? So that was my question, and I provided a set of questions along with some of the code and saying, hey, can you help me out? And actually one of our developers, Brian Ekins, super awesome guy, wrote back and had this really clarifying answer for me about where it's coming from. And so I was able to take that, and so it's your job then is participating in the community. Is if the information that you get back from the community is super helpful, make sure you say as much. So I did that, and actually after I took his advice, I said that cool, this is what I did to get it to work. Thanks so much. And then he actually had a little bit more, so we had kind of a back and forth. And then I'm posting this, and so when you're ready to say that it's done, go ahead and you can, if this is correct, you can accept it as a solution. That's what's done here. This is a solution to that problem. And again, this is being this was accepted as a solution, and now this is available for everybody else in the community to use. And so you won't have that question is going to be a lot more discoverable. So that's really important that you guys participate in that. And this is this basically way I was able to go beyond stuff I was able to find in our documentation. So with that, guys, that is that is a long first getting started tutorial, and I have a video of kind of using the final version of what I've done with this particular Fibonacci script, and so that's in the notes here before. I hope this was useful for you. I'm going to continue developing stuff. I hope you guys too. Let me know what you guys end up creating. Again, I'm on Twitter. I'm at Michael_Aubry. I am on the forums active here. Those are the best ways to engage with me. I'm really excited to see what you create, and I hope this was useful. Have a great day. Bye.